Okay, so this lesson is 8.3 in your textbook, page 527. We're talking about sinusoidal functions. Okay, have I talked to you about sinusoidal before? Have we mentioned that in this class? Okay. Yeah, okay, good. So sinusoidal would be the shape of the graph, like that kind of emulates a sine shape or a sine graph. And so this sort of undulating, sort of repeating, periodic sort of function is called a sinusoidal shape. And it's actually right here. The sinusoidal function is any periodic function whose graph is the same shape as y equals sine. And of course, sine is in the name, sinusoidal. Okay, so it's the type of function that would emulate sort of this sine function. And we're going to talk today about real-life situations that would, a sine graph would do a really good job in representing. Okay, I'll come back to that if you didn't get that down. All right, so on page 527, you see this. Okay, it says that students in Simone's graduating class went on an exchange trip to China. While they were there, they rode the Star of Nanchang, one of the tallest Ferris wheels in the world. Simone graphed the sinusoidal function that represented her ride. Okay, so here's the big Ferris wheel there. Okay, anybody been on this one? Got a couple Chinese people. No, yeah, never seen it. Nanchang, did I say that right? Nanchang? No? Okay, probably not. How do you say that right? You never heard that before either? Well, I don't feel bad then, because I've never heard that before either. Hey, do you know what I'm talking about? No. Okay. All right, we'll move on. Perfect. Okay. Anyways, I believe that would be the picture of this Ferris wheel. And those little dots there, yeah, that's like, there's people in there. And this looks like it's like 1,000,000 miles high. It's definitely the hugest thing I've ever seen. Would you catch me on there? Probably not. If I wasn't breathing and for some strange reason I died and they put my body on there, that might be the only way. Got it? But I digress. Okay. All right. So let's keep going. Back to math. Thank you. As you can probably, why would I be recording this? Of course not. Yes, I am recording, actually. Shut up. I'm going to have to erase all this now. Okay. Focus. All right, so look at this. Star of Nanchang. Oh, okay, you know, what is it? Nanchang? Star of Nanchang. Nanchang. Is that better? Ferris wheel ride. Star of Nanchang. Okay, I can't do that. So obviously, look at this. This is height, and this is time. So as time goes on in minutes, all right, look at this. Look at how long it takes to get from the bottom to the top. This is what's amazing about this. The bottom to the top, how many minutes? 15 minutes from the lowest point to the that seems unreal to me. 15 minutes? Wow, that must be going super slow. Or else it really is 1,000,000 miles high. So how high is it in meters? Look at this right here, this point. That is the point that corresponds to the highest point on the graph, 160 meters. Okay? 160 meters, that's a lot. Okay? All right, so this graph tells us a whole bunch of stuff. It tells us, look at this point here, the lowest point is 0, 2. What does this mean? What does that mean? Can anyone tell me what that means? Yeah, go ahead, shout it out. It means you start 2 meters above the ground. Very good. That means you would get on the ride. Picture the ride. You get on the ride 2 meters above the ground. Look at that. Ish. Okay? So 2 meters above the ground is where you start. And this up here, okay, they're not breathing a lot of oxygen up there because it's so high. Okay? I think they maybe give you an oxygen tank down here so when you get up there you can actually continue to live. But that's 160 meters above the ground. Okay? So, no, not a kilometer. No, that's 1,600 meters. Yeah, thank you. It's not a kilometer. All right, so I got a question for you. What's the radius of this Ferris wheel? What is the radius of this Ferris wheel? Careful. I heard the right answer. Okay. Okay, now everyone focus. Look at this. The top to the very bottom, that is 158 meters. What's half of 158? 79. The radius of this wheel is 79 meters. Get that? Okay, from the ground, right here, 0, this Ferris wheel reaches 160 meters up in the air. See that? That's the maximum height. The fact that the wheel doesn't go down and scrape the ground at 0, 0, it actually starts at 0, 2. So that means it's 2 meters off the ground. So from 2 meters to 160 meters, that is 158 meters, right? And therefore, half of 158 divided by 2 is 79. So that would be the radius of the wheel from the middle to the top. Also, what is that also called in this equation or in this function? Amplitude. Thank you, from yesterday. Very good. So what's the range? What's the range of this? What is the range of the function here? Okay, you guys don't remember what the range is? The range is all possible values of y. So what's the smallest value of y we have here is 2, and the largest is 160. So the range is from 2 to 160. Y value is between 2 and 160. So you maybe write that like this. The range equals, it's funny brackets, okay, 2 less than or equal to y less than or equal to 160. That's how you would write that. The range is from 2 to 160, including those two values. That's the range. Okay? Now, domain, here, if you just look at the domain, it starts at 0, it ends at 60 minutes, so an hour. And in 1 hour, look at this, in 1 hour, you have only gone around 2 times. See, you start at the bottom, you go around up to the top, then back down to your starting position, and then a second time in 1 hour. That's amazing. Okay. What's that big thing? Okay. So we can determine a lot of things from this graph, right? We can determine the maximum height, the minimum height, we can determine how big the wheel is, we can determine how long it takes to get back to the bottom, okay? And in 1 hour, you'd only go around this thing twice. Now, there may be stops to let people on and off, who knows, but this is the equation, okay, that they provide you. That's the graph. Okay, so we answered a bunch of those questions. All right, let's move on to example 1 in your text. You see example 1, page 529. We're going to do the same thing to a different graph. So this is just a graph, not necessarily of a Ferris wheel or whatever like that, but this is just a graph. And we're going to ask, it says describe the graph by determining the range, equation of its midline, the amplitude, and the period. So we learned all these terms yesterday, and now we're going to look at a graph and we're going to determine all of this stuff. Okay? So let's start with the range. All right? What is the range? What's the lowest point here? Good. -3 is the lowest point. And the top, the highest value here is 7. So the range is, now when you look at this, you can just count, right? 7, and then 3 is 10. So how can we figure this out if you can't just see it? Well, you go max minus min, and that always works. That's the range. The range. So the range, it's 10 units, because that's 7 minus -3, and you would write the range like this, from -3 less than or equal to y less than or equal to 7. Okay? So that's the range, and it spans 10 units, which we'll use that a little bit later. Good? Question about that? No? Yes? Okay, let's pop over here and take a look at the equation of the midline. Now, the midline is the line that's right in the middle. Okay? And if you want to count squares, go ahead. We know that this is 10 units, right? Because we did this over here. It's 10 units. So if you subtract 5 from the max, or you add 5 from the minimum, you will get where the middle is, because 5 is half of 10. So once again, whatever this, span is, okay, divide that by 2, and then add it to the minimum, or subtract it from the maximum, and you'll get your midline. It's always a line, a horizontal line, so it's y equals, and then what is 7 minus half of 10? 7 minus 5 is 2. So the equation of the midline is y equals 2. And if you were to draw it, you would draw it right here, and that should be exactly halfway between the maximum point and the middle point. Yes, got it? Good. Questions? All right, so let's erase some stuff here and let's make some more room to work. So y equals 2 is the equation of the horizontal line. If you're looking for a vertical line, that would be x equals. That's the equation of a vertical line. But the equation of a horizontal line is y equals. Okay, so amplitude, we've kind of already calculated amplitude, haven't we? That is half of the total span here, half of this range of values. And so the amplitude is 5 units, because that's 10 units divided by 2. Or you count it from the midline up. 1, 2, 3, 4, 5. And the period. Okay. The period might be a little tricky, but you've got to look carefully at this graph. And you say, okay, where's a start line, where's an end line that we know of? Well, if you look here, you could look at 120 and look at where 120 intercepts the line. That is at 120 degrees. Everybody see that? So you could do this, and you say, where is the next point? Where's the end of this cycle? It's right there. So you could do it this way. Find out if start point, 120. And then this one, this isn't labeled, unfortunately, but it's halfway between 240 and 360. So between 240 and 360, that's 120, right? So half of 120 would be 60. So 240 plus 60 should be 300. Does everyone see that? You're calculating where this point is on the x-axis. So then the period would be 360 degrees, this point, minus 120, which is what? 240 degrees? Does that make sense? Now let's see if that's right. An easier way, maybe, or another way to look at this. You go from this point, which appears to be the lowest point, right, to the next lowest point. Okay? Which is something's wrong here. There to there. There to there. There to there. Yeah, it should be the same distance. So what do we do? Oh, sorry. You guys didn't catch that? You guys all sleeping or what? 300. Yes? I think you are. Okay. I wrote down the wrong number. So it's 300, not 360, right? This one is 300 here. So 300 minus 120 is what? Okay, wake up. Everybody wake up. I see you guys all like falling asleep on me. What's 300 minus 120? 180. Thank you. Okay. So that's correct. This should have been a 0, not a 6. So why did we double check that? It's a good thing to double check. Why? Because this point to this point, this right here is 180. So 180. So this is one cycle, this is one cycle, and this is one cycle. Got it? Okay. So we take a look at example 2, a lot of the same stuff. It is determine the range, determine the midline, determine the amplitude, determine the period. Okay, so from last lesson, if you're not sure about those terms, you have to look back to your notes. Okay, watch the video again if you need to. But those terms you need to know. You need to know what those are. So the range, okay,